Hello guys, welcome to the channel. Today we will be solving this problem of the day at LeetCode. Today is 24th Jan 2026. Today is this problem is not medium. I will say it's an easy problem. Okay, and then we will see uh, how to solve this problem. So we are given an array. Let me describe the problem statement first. So I will be, explaining the shorter version of this problem. I will not go, word by word in the problem description. So the short problem is we are given an array, we're given a array. We have to pair the elements. So of course the pair will be of size 2 only, and we are also given that the array size is even. The array size is even. So there will be n by 2 pairs in total. Now we want to see how, so basically let's say we have some elements A1, A2, A3, A4, A5, A6, okay? Now, and we have to pair some elements. Let's say if we pair up A1 and A3, we pair up A2 and A4. We can pair any element with any other element as long as the other element is not paired up and the current element as well. So what to do next, right? So we have to pair these elements very optimally such that the maximum pair sum is minimized. Okay. Now generally in this kind of problems where the most important observation you should make is that the order doesn't matter. Here, the order doesn't matter. What it means? It means that we can sort the array. So now let's say, without loss of generality, we have we have our array sorted. Okay, so we have just sorted our array. Okay, this is the most important thing you should know. You have to solve this kind of problems where the order doesn't matter. You can always sort the array first. Okay, even if it is not required, you should sort the array, and it always helps to simplify things. Okay, so now let's say we want to pair up things, right? We want to pair up in such a way that the sum should be minimum, the maximum sum should be minimum. Okay, maximum pair sum should be minimum possible, should be minimized. Now what should we do? Okay, we know that these elements are sorted now. Okay, these are sorted. So now without loss of generality, okay, let's try to pair up. What I mean, greedy approach can you follow to pair up these elements? So if if you try to, of course, these two elements will be closest to each other. These two elements will be closest to each other. This will be closest. I mean, for this will be the closest one. For this will be the closest one. And for this will be the closest one. Okay, but now you will say that okay, this is the minimum pair possible. Then this is another minimum pair possible, and then but we have to focus on the maximum pairs. Okay, and so if you do with this approach, if you go with this approach, you will find that a maximum pair possible in this. This was the maximum pair possible. So we can't really minimize that. Okay. So what can we do is, as we have the elements sorted. Okay. So my hypothesis is that we will always pair up the first element with the last one. Okay, like this, and we will always pair up second last with the second element. Similarly, third element with the third last. Okay. Now, why is it, why is it beneficial? Why it will always give us the optimal answer? So here is the proof. Okay. Let's say we pair off even with other element. It's instead of A6, right? So of course the A6. My hypothesis is that the maximum element should be paired up with the minimum one. Okay. Now let's see if I try if with A6 I try to pair up any other element. Okay, let's say A2 or A3 or A4, it will be always greater. So this is what I'm saying. Any other AI where I is greater than, okay, let me erase this, where I is greater than 1 and it is between n. Okay. Now this gives us a lot of base for the proof. Like, if we don't pair up with AI, and we pair up with some other element, of course, this will exceed the the previous best. Okay, this was the candidate. These were the two candidates which we taken into consideration, but we found out that this is always the minimum possible. Okay. So for A6, the best thing to pair up is always A1. Now as A1 is gone, A6 is also gone. Similarly for A5, what will be the best one? Only this is the best one, right? Uh, Okay, now we can erase that as well, and we can erase. And for similarly A4, A3 will be the minimum one. Okay. Now if this is our answer. Now, if you try to say that, let's say if we try to say that, okay, this may be false. Okay, let's try to prove this hypothesis false. Okay, so what other thing can we do to prove this statement false? Okay, so what I'm doing is, so previously we had paired A6 with A1, right? Now, and we want to pair up and this will be the maximum possible, right? We want to make it as the maximum possible thing. Okay. So if you try with any other thing, let's say E3, now, okay, this becomes your maximum thing. Okay. Or this is your, let's say, I mean, second maximum pair sum. Okay. This become our second maximum pair sum. And now this becomes, let's say A2 and A5 is our, maximum pair sum, okay? This can happen very well, right? Because, can this happen? So, I'm not sure about this, so let me, try some cases. We want A2 plus A5 to be greater than or equals to A3 plus A6. Can this ever happen? Okay. Let's try some things. Okay, we want E2 plus E5 should be greater than equal to E3 plus E6. I'm thinking, So this is clear that it should be strictly greater. Otherwise it will be of no benefit, right? So A2 should be paired up with A5. So let's say if I take A2 as 5, then A3 as 2. Now this get cancels out. Okay. And A5 is still if I cannot now it comes to A5 greater than A6. So this is false, right? Because we have sorted the array and this is not even possible. Why did I do that? So we know that amongst A2 and A3, A2 must be less than equal to A3. So I pick the threshold like it is equal to A3 in the I mean in the best case. Okay, the maximum bound of A2 will be equal to A3. So that's why if both are equal, we can cancel things out. If A2 is less than A3, then it makes a lot easier. Let's say this is 1, this is 2, and this will be, of course, 3 and 4 or 3 and 3, right? Okay. Now, we will never get this condition true, which proves our statement wrong that like the best pair like this is never possible. Okay. I think I over explained this problem, but the simple solution is that we will sort the array like A1, A2, A3, A4, A5, A6 up to AN minus, let's say AN, where n is even. We'll pair A1 with AN, 2 with AN minus 1, 3 with something, and 4 with, and at the end, 4 with 5, something like that. Okay. So we'll make something like this structure. Now, how do you implement this? So, even if you thought logically, okay, you can get to this solution. Like you can implement it by yourself. Okay. So let's index them. The way I have implemented is like this. So we take two pointers. So here there will be my I pointer. Here will be my j pointer. Okay, j will be equals to n minus 1. Okay, so here it's 5. Okay, so now I will pair up a1 and a6. Okay, I will do j minus minus and then I plus plus. So I will jump over here, j will jump over here. Okay, now I take this sum, stored it. I will take maximum where sum possible. Okay, I will keep on tracking maximum of ai plus aj. Okay, overall I less than equal to n by 2. This I will be, of course, will run for n by 2 times, like here. It will stop over here, right? Because j will be also here, and then I should not exceed j. So, okay, I hope it's clear to you. Now, the other thing is why we are tracking maximum. Uh, why can't we just, take, if you are thinking like this will be the maximum pair possible. Uh, let's make it if you're thinking like this, you may be wrong because let's say if this is 1 and this is 5 and all of us between are let's say 3. Okay, 3 3 3 3. Now you got right a2 and a5 just got sum as 6 which is greater than 5, so the maximum uh, pair sum has to be tracked. But this is the optimal answer, and this was the proof for that, like why it's true, right? Okay, now if it's clear, let's solve the problem. Okay, let me reset it. So what we will do is first of all just take size of the nums. Then, as I said, we will maintain our answer. our answer, let's assume it's 0 because every element is greater than equal to 1. So that will work. Now we take two pointers, I is equals to 0, j is equals to n minus 1. Now here is a classic two pointer thing, two pointer condition. Like if I is greater is less than j, mind it like it's not less than equal to, right? If even if it's equal to, it will work because n is even, I guess. We'll see. Okay. Now what is our pair sum? Pair sum will be, as I said, it will be nums of I plus nums of j. Okay. And then answer will be max of pair sum comma answer, right? And we want to do I plus plus, then j minus minus, and then just return answer. Let's run it. Uh, we got the wrong answer. Why is it so? Because we have not sorted there. Okay, we should sort the. Okay, this was the first statement. Never forget this. Okay, now it's working. We can submit it, right? Okay. The other way to implement, okay, let me try. If what if it was less than equal to? Will it work? I think so. It will work because as n is even, it always it will never happen that I is equal to j. Okay. So that's the last one. Another implementation can be like this. Now, okay, before that, let's see what is the time complexity of the code. If you think very properly, this is an important observation. Like we are doing I plus plus and j minus minus at the same time. So if you imagine two pointers on the end of the array, okay, a, my I was firstly over here, my j was over here. Now I do I plus plus. I gets here, j gets something over here, right? Now, continuously, forwarding the I pointer, and backwarding the j pointer. It will always happen that there are two elements. There are two elements. Like here will be j and here will be I. So what will be this value? I mean, what will be this length up to which I was traversed, and what will be this length up to which j was traversed? Now I think it's self-explanatory that okay, it will be always n by 2 because we are doing I less than j, and we are always doing I plus plus j minus minus. Okay, we are always doing I plus plus j minus minus. So what this means? This is important for me. We are doing I plus plus and j minus minus. Let's see what happens. Okay, a n minus 1, then a n. Okay, now if you see, like if I was previously here, then j was previously here. How many elements are present in the array? Like between this whole range. Okay, it is of course n, right? Initially, the total elements present were n. When we do I plus plus and then j minus minus, what happens? We are doing both simultaneously, right? Both these things are getting are executed simultaneously. I mean, not yeah, simultaneously. Now, if I say I plus plus j minus minus, what happens? Like if I goes over here and j goes over here, how many elements are there now? It is of course on the second iteration, the elements are now n minus 2 because this got skipped and this also got skipped. So continuously doing that, what how much long will it go, right? We are always subtracting 2 from it. Okay, now if you come up with the observations, like let's say it is 6. So say if we subtract 2 from it, then again 2 from it, and finally it becomes 0. So how many times it was positive? It was three times. For 8, we get to 6, 4, then 2 again 0. Now you can see it was 4 for it and it was 3 for it. For 2, it will be only 1. So you can make observation like this. It's always n by 2. So that's why the time complexity of this code will be big of n by 2. Okay. No, I mean, not actually this thing because n by 2 is only up to this part. Okay. But we never considered the sorting of the array. But the sorting unfortunately takes n log n time. So of course, the time complexity of this code will be of n by 2. So first of all, sorting of n log n plus n by 2. Okay, this is the time complexity in the worst case. So I hope it's clear. I will, also mention, type other implementation. So here we don't need two pointers. We just need to track of this thing, right? I. So now for pair sum will be ith element will be paired with which thing, right? It will be paired with the last ith element, right? And we will simply take max of answer and pairs and then return once. This is another method of implementation. Forgot it's not array error, it's nums. Oh, should work, right? If it works for it, it will work for either. Here we just saved a single variable, right? That int g. Okay, thank you so much for watching. I hope you got it.